before I start the integration part, I would like to share with you the notation. Alright, for example, I have a certain input E, alright, which is over here. I add in its previous output, alright, because the output comes from here, right, U. So it output becomes my previous output, alright, my previous output. At the end of the day, I will have a new input, so to speak. Alright, so the U itself, alright, is a notation for output, while the E is a notation of input. So far so good. And that the coefficient, because you can amplify the signal, alright, so the coefficient for U, which is the output, is negative. It's because there's a negative sign in the feedback system. Alright, so the next step, if you have the new output, so this new output will become the previous output and feedback all the way here, mixed with the new input, mixed with the input, and you come out a new output, some sort of the meaning. Alright, but as for integration, it's all talking about U and E now, right? So therefore U, let's talk about it as output, E as input. So later on when we talk about it, it's easier to talk about it. And the following is somewhat of my intuition, to my best knowledge, so I may be wrong. So for example, in the Euler system, alright, you have certain digital signal over here. And then for Euler's method, in the previous part, we actually say that when you use the Euler's method, you're actually connecting this curvature. Alright, while integration, instead of connecting the curvature into the curvature, you have a certain points, same points, but however, you can take information to get the so-called the forward information, or you can also take information from the previous information. Alright, so you have certain input of information. You can either go forward to get the front part of its information, or you can go backward to get its previous part of the information. Alright, this is somewhat from the equation that I've seen over here. Okay, so therefore integration, you can get the integration of under its signal, so therefore it's shaded over here. Alright, and so differentiation is to just to create a curve, while the integration is to somewhat find the area under this curve. Alright, but the meaning of that, I really don't know what's the area under the signal curve. But anyway, that's the purpose of it. And therefore, what is this all about? Alright, now similar to Euler's, integration has also rectangular forward rule and backward rectangular. Rectangular means that it's a rectangular shape. If it's a trapezoid, then it's a trapezoid shape. Okay, now for the forward, as I say, I'm actually taking the forward information, whatever that is in front of us. And therefore, as you can see, if I feed in a previous output, alright, a mix, which is over here, I feed in the previous output, I tap into the data of the previous input. Alright, what I have is the next output, UK. Now I have feedback over here, and then I tap in this output, I tap it into here, I tap it into here, this is the new line, I'll get my new EK, and then I'll just fit it in, I'll get my new position for my UK, UK plus 1, and then so on and so forth. Alright, this is for the forward. Now for the backward, instead of going in this direction, I actually fit into this direction. In other words, I fit in my UK, I go in this direction. When I fit in my UK, I can have the information of my previous input, right? What input that comes up to give me myself, right? So I give me my information. So therefore I input in this direction, I come here, I get this information of my own EK. Alright, once I get my own EK, I can compute and realize that okay, I have my previous output, and I'll just go in this manner. I'll go in the opposite manner. I have my previous stuff, which is uk minus 1, alright, which is somewhere over here. Alright, and then once you get the certain point of the uk minus 1, then you fit in the uk minus 1, you get this point, you get your new t ek minus 1, and then you just go back all the way. So you are going in the opposite. I know what I've just said earlier is a bit what uk minus 1 minus 1 here and there, but the concept is just to go back in the backward loop. Alright, this one is to the forward loop, and I may be potentially wrong, so yeah, just take note of it. Then trapezoid is simply that, similar concept to this, I would believe. It is not similar. It takes in 2 points. Alright, actually fit in 2 points, fit in 2 inputs, as you can see, ek and k minus 1, and then you sort of mix them together and divide it by 2. Alright, and therefore you get something that is under the curve. That's why I say this is something very abstract, because I have no equation to prove anything, so therefore this is something of that meaning to integration. Alright, but before I go, you may be wondering what is this thing, integration from 1, 0 et. This is when you are talking about continuous system. Alright, then you integrate everything. As for digital system, because it's all dots, you want to integrate, and therefore this is why we use these formulas. Alright, and the t is simply the difference of time, t. Alright, this t, the time step. Alright, and therefore I'll leave you to this, and we'll see how do we integrate in the next stuff. Goodbye.